Everyone, today I'll be explaining how you will plot your table in Paper 3 Chemistry 9701. If you read from your bureau after you finished everything and there was a color change, so you read maybe let's take an easy number, 20.00. So what did you notice that we added the 0.00? So that's something that you should realize. You can't just go and write your value as, yes, I got my reading as 20. That's wrong. You should always put it to two decimal places, and this will be one of the marks for accuracy. So the rough will have its own table, which I do it like this. It won't be that perfect. I mean, the length it won't be that perfect, but I'm telling you, I assure you everything will be just like you wanted. Alright? So you write here rough, and then you will cut this into 3. Alright? You write here the initial volume. And there's also another point you need to focus in. You need to write the unit of whatever you're plotting in the same table that you wrote the name of whatever you're plotting. You can either write it as slash centimeter cube, or you can put it like this. Alright, but never the exact. Them together is so wrong, so you won't get the mark for it. But for you to just finish this all, just make it centimeter cube 3 with the slash. Okay, so we know it's initial volume, and for sure we have a final volume as well. Final volume again, and then here will be the volume of whatever the amount of solution here. For example, let's say that this is Fa2. In the question they will mention if the burette was filled with Fa2, means you're using Fa2. So you write here volume of Fa2 used, again slash centimeter cube. Now this will for sure give you marks in fact, so please, it's an easy marks for it to get this. Alright, and now the rough value is like, I won't say it should be the most accurate value you should do, but you should try your best to have it accurate, because the thing in this type of exams that they will make it that your rough values on all your upcoming experiment as well in the titration, they should be based on your teachers. Alright, so now you think, yes, rough, so I can just pick up any number, so it's rough, it's rough, it's not accurate, but it should be within the teacher's value, so you should be sure to make the rough a little bit accurate, so you won't lose mark for the accuracy based on your teachers if you were in the school same as her, so because it will be based on her results for you to get the marks. Let's say you got 20.00 and this is close to the teacher's answer, so you will put, that was your very first experiment, by the way, very first time to do the experiment, you're gonna say that this is the rough. So initial volume, here you got, in fact, here is your final volume, and you know the very like first thing you had is the solution, which the solution was reaching to 0, right? And then after you kept on like putting it down until there was a color change, you will realize that it reached 20. So 20.00 is the final volume, and 0 was where the solution was at the very first. It's really depending on you. If you start the solution here till it goes to 20, really depending on you, but I really highly recommend that it will always start with 0, so you won't have much time to like minus whatever. So just always keep the initial volume as 0. And now again, you don't put 0 as it is, you should always give it 2 decimal places. If you do not but due to decimal places you will in fact lose marks. Final volume, as we said, 20.00, and then the volume of Fa2 used is basically them minus together. That's why there's no need to minus them together, because the initial volume was 0. So that's why I'm again recommending you guys to always have initial volume of 0. So it's the exact same thing. So it's 20 minus 0, what is 20? Now, we do not recommend you to again use your rough value to make it to the other two. So you should do the experiment once again till you see the card change, you see where the solution reaches, so that will be your final volume. Alright, so let's say you did it 2 times, alright? So your value was like 20, right? What if you example? Let's say since you did it so accurately, I'd say maybe you got 20.45. 20.35. So I did the experiment of the titration 2 times accurately. Like, you should have it the same results, same range as the results of your teacher, and your values were 20.45 to 20.35. And now something for you. Now there's for sure, you know, and there's I, triple I, V, 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 I, V, double I, which are, you have 7 marks for you to get the whole marks for the table, right? And the last 3, the V, the 5, 6, and 7, they are marks for the accuracy. Here is where your numbers really matters. It's not only that your values should be based on the teachers, but they also should make sense. Now, 20.45 minus 20.35, you have a difference of 0.1. Did you notice that? Now there's something I want you guys to learn. Always, when you do experiments in the other part of the question where you should do them accurately, the maximum difference you should have is 0.1. Do you get it? For example, if your second experiment, your second time doing the experiment was not 20.35, it was, let's say you got 21, in fact 21 instead. So it will make no sense, because 21 minus 20.45, your difference is 0.55. The difference between these two is 0.55 centimeter, and which is way more than 0.1. Because my point is, for you to get the accuracy between the times of the times you did the experiments, they should have a difference of 0.1. because if you did not have a difference of 0.1 max, okay, like you did not have a difference within 0.1 or a difference that exceeds 0.1, you will in fact not get the accuracy marks. It will make sense until I give you again. You will do the table, alright? You can follow the same format. So what will I do? I'll make the table first thing. Now our values is 20.45 and 20.35, alright? 20.45 was your first accurate one. This is not your rough one, this is an accurate one. So initial volume is 0.0 again, 2 decimal places. The final volume of trial 1 we said is 20.45. And the volume of FA to use is difference between them. 20.45 minus 0 is 20.45. Now for trial 2, we said we got 20.35, but first the initial volume, you will do the experiment once again from 0, so you will make it hard for yourself. Now we got the final volume, this is 20.35. The volume of Fa2Us is the difference between them, which is 20.35 minus 0. 20.35. Now you got the full marks, full 7 marks for this y. Now let's count everything that will give you the marks. The way you form the table with the units will give you, I'd say, 2 marks. Alright? Having 2 decimal places, like the format of your numbers, will give you, again, marks. I don't remember exact how much marks, because we don't have the marks scheme to show which we're talking about, but I have an idea about whatever will give you the marks. So again, the way you form the table and the decimal places, the format of the numbers, and so on. And now the last marks, which are V, VI, VI, these are called the accuracy marks, which are 3 marks, right? And you won't get them unless your marks, your values make sense. Again, what was my point that I said? That the values, let's write them down. Alright. Important point. Values, no, accurate, accurate values should have a difference of 0.1 max. What does that mean? If you did the difference between 20.45, 20.35, their difference is max 0.1 centimeter tree, and we said the accurate values should have a difference of 0.1, right? And this will give you the full marks of these 3, because they want your accurate results, and these 2, they're accurate, showing that you did your experiment correctly. Do you understand that the difference between these are 0.1? What if you instead got, let's say, even got a better accurate result? You got 20.4, which is literally how much? 20.45 minus 20.40. You have a difference of 0.05, which is even way better. We said the difference should be 0.1 max, right? So 0.05 is less than 0.1, right? So it means that it's way more accurate. It's just like better, you know. It's either way. If you put 20.35 or 20.40, you'll get the result. You'll get the accurate results. But it really does not matter in here. The max, what matters is you got a difference of 0.1 max. If your difference was like 0.2 or 0.15, you in fact did not get the accurate results. In this case, we changed it at the very last. With the difference of the titers in here, from Fa2Us is 0.05, which is way better, which is in the range of the max 0.1. But let's make it back to whatever it was, so you guys won't get confused. Your difference is 0.1. So you got, in fact, the accurate marks, which is actually good job. Now, something that will really really colorate between the rough and the accurate results. The rough and trial 1. Now, let's say we have another rule. Difference difference of your trial one and rough is 0.5 max. Is the difference of the trial one, which is the first one of the accurate titration that you did, in the second part of the question, if you checked in the past paper, and the rough difference should be 0.5 max. What do I mean? Here we said that the volume of FA2 used is 20.0, right? And the volume of FA2 used in the accurate one was 20.45. 20.45 minus 20 is, you're at the edge, by the way. Not really at the edge, but you could say the edge, because the difference between them is 0.45. 20.45 minus 20, you got difference of 0.45, which meets the difference, which meets the whatever I said of 0.5 max. So you in fact got the accuracy mark of the rough. So it means that your rough is really not a rough value. It's like it's not mean your rough was like a random number, because your number of rough and the trial was within 0.5 max. Your difference between 20 and 20.45 were 0.45, which is within 0.5. So it really is correct. So that's why difference really matters, to show Cambridge that you have an idea of what you're doing and your experiments, your values are accurate. And then furthermore in the question, they will be asking you about find the average rate. Should know it by now. It will be the part B of the question. For example, we have here, from your accurate titration results, obtain a suitable value to be used in your calculation. Furthermore, close in titration, you will have a stoichiochemistry part of calculation. So in part B, you should have the average of your accurate results. In this case, since our trial 1 and trial 2 were accurate because their difference was 0.1 max, was within the 0.1 max here, meaning you can use them. And for you to show Cambridge that they are the values that you picked, you should show them a check, meaning that yes, I picked 20.45 and I picked 20.35 because their difference was 0.1, meaning that the difference was within the accurate difference, which is 0.1.